All right, you guys, what's up? This is another session of Max MSP with Cujo Sound, and I'm Bjørn Jacobsen, and let's get right to it. So we previously looked at some basic math. Not linguistics or languages. No, basic math, and how to signal path our way out of subpatches and my nano controller here into whatever we have and whatever we want to use it for. We showed that the input of the microphone can be used to have a meter pop out and tell us that input is working, and so on. So let's get to it and play some other sounds here. Now, we're going to add an ADC, which is the analog to digital conversion, as mentioned before in the other episodes. This is the whatever I'm saying into the microphone comes into the patch. But there's the other equivalent of that called the DAC. We may have heard of that because DAC is a common thing on, let's say, CD players and so on. It usually says that. So DAC stands for digital to analog conversion, which is basically what's coming out of the speakers. So we're going to be using up here the toggle that we had before from the button that I'm pressing. And the DSP status here, as you can see, it turns on and off whenever I do stuff. And the same thing goes for this one here. You could send the toggle to that one. You only need to send the toggle once to turn on input and output. And we had this little basic multiplication system that we had there. So let's try and in here and say we want the float value from our nano controller to come in here, and the DAC to come in here. So now that I'm speaking, and if I turn up the volume, you can see the meter react to what I'm saying. Now, if I send this signal here to the DAC and start talking, you can basically hear the feedback that's coming out of it. It's only coming out of the left channel right now. That's because the DAC has two outputs, which is left and right. So if we drag and drop it to the right one as well, it'll also come out of the right channel. Woohoo, right? So before we get all too excited about my voice that's coming out of the speaker, why don't we go back to that very object that we showed in one of the first episodes called SF Play. SF Play can load samples and it can play them back. I've prepared a sound which is a really, really long one so we can have it going. We can try it out. So first we're going to do it into the meter down here so you can see that it's actually working. This here is SF Play, stand for sound file playback. If you hold Alt and double click it, you can see when it's done loading. A very nice patch here which shows how SF Play works. There's a lot of stuff to it. But what we need today, or what we need right now, is a message. Because if you check the inlet here, it says that integer plays the cue, whatever the cue you've set, which is another thing, and 0 stops it. That means that we can send a toggle to it. Let's just send this toggle here so that we use our second toggle, which is the M button here, which then starts and stops playback on this one here. But it also needs, if you look at it here, it says that it needs a signal and message. The message called open opens the file. So we press M and you make a message called open, like that, and you attach it to it like this. But you can also just click it and you get this nice list of whatever it can do. So if we say here, let's say we want an open like that. That's $1. $1 is a variable, but it just says open. So that is, if you click the inlet, you get a list of the most common things that you can pop into this, and it'll automatically generate it for you. So here we have a message called open. Now, if I hold control, like our patch is locked, and we activate this open here, it'll open up a menu like this. And I'll be able to double click this here, Max Audio, which is the file that I created. So now that file is loaded into this one, which means that when I press M over here and we turn on the toggle for this to play, this value here becomes 1, and as we just saw in here, the integer, whatever integer above 0 means play. So one of the problems about this is that this only takes a value between 0 and 1. It doesn't take a value that is 127. So even if I press this button and turn on this toggle, it'll send the value 127 forward to it. So as you can see, if we drag and drop this down here, no sound is coming through. But if I create my own toggle, which sends the value of 1 and send it straight in here, it then works. So for this button up here to work, we would need a new divided by 127, go there, and there, and there. Now, and it just starts over whenever that happens. We could also here say a message with the value 1. We can click it like this. So it also has a, whenever it's done playing, could be like 10 seconds long or something like that. Whenever this plays, when it's done playing, this button here bangs. So if we add a toggle here, like that. Once it's done playing, it sends the value to that one, which means that we can use this one here up here, this value, this bang here, to toggle this again. So now it's playing again, and you will then know that when it's done playing, this should turn off, but it should bang itself up here and restart. So we can actually make a comment by pressing C here. Did it loop? Isn't that fantastic? Things work the way they're intended. Wow. So we put in a new message. You press N and type message. That's the same as pressing M. We just in this message here type 0. These are basically now start and stop buttons for this. So we could make a comment pressing C and say start. Here we go. Make this smaller just for aesthetics. Copy paste it, and here we write stop. So now we have a start and stop button for our sample here. And that comes out, and it's volume controllable because it goes through our multiplication tilde of it here, which we can then control with our fader. And that works really well. So that's basic inputs from an SF play file. Now let's go into the help file, the reference file of the SF play here, and see what we can find. So here, as you can see, it has all these values here that you can send it as a message. It's like open, 1, 2, play cue number 2. If you define a cue, stop playback. You can also seek, which means that you can generate random numbers and have it seek to specific locations, which is also quite interesting. You can preload 2, that's defining cue number 2 and playback at 700 milliseconds, which means that you can preload as many, basically unlimited amounts of cues that you want. And then if you send the value 2 or 127, which is why 1 doesn't work, as we saw before, then we can have cue number on 127, which means that instead of having 1,000 files or 127 files, you can have one file with different values inside it. So this here, define cue 5 to start at 900 and the end of the file, and it should play to 1200 milliseconds. It only plays that, which means that then you get a bang when it's done playing the cue, which means that you don't necessarily, you can make this really long file of saying, this really long sentence, you want it to start in the middle of the sentence and you want it to end at some other place in the sentence, and then that also works. You can also send all these messages where it clears it and so on. And it's pretty cool. It's pretty cool. Easy to use, at least. And in that way, you can have it to play back samples. Now, what if I want to, you can basically use this as a sampler. So let's make a new one here. And there is one called key. And it has, let's make an integer here. So this here is the ASCII value of whatever key that I'm pressing. So let's say if we lock it. And when I'm hitting the keyboard, as you can see, all these values come in. So let's say 113. Do this and say new select or cell 113. That means that any value that is not 113 comes out here. So it bangs if the signal matches 113. We send that to our 1. We can put a button here to see if it does. So every time I press Q, it should send a signal here into this select event object here, which select it, and every time I press something else, it bangs this signal here. So if we lock it and I press R, E, W, and Q, and then it does that, which means that the Q button is now my play button. And let's say if anything else is now my stop. So now Q and W, Q and whatever P is now my start and stop button. It's a very easy way of having something to be controlled in and out. So that's very basic stuff. Very basic of how to control input signals. And that's it for this video. It's basic keyboard input and output and how to use the SF Play. Don't forget to hit the like button if you like this. Click subscribe on Patreon, YouTube, Facebook, Instagram, or Twitter. Whatever you feel like, whatever rocks your socks. Hopefully I'll see you again in episode 5. Have a good one.